Hi everyone, and welcome to this training video. In this video, I show you how to ingest JSON file as a semi-structured data from internal namespace into Snowflake table in Medallion architecture in bronze layer, doing transformation in silver layer, and building data warehouse model in gold layer ready for visualization. Great. Let me first create the free account in Snowflake. In order to create the free account, you can type free account Snowflake, and here you can click this link, and you can find here you can enter your name and so fill these options. Here we use the Microsoft Azure. You can use AWS and Google as well. And company name is not is optional, and you can choose as required. You can type anything. I type something and something. And here the nearest region, and you can mark this option and first, let me fill it. Oh, boss. Yes. And escape. Escape. And you is setting up. As soon as the setting up account finish, you will receive the email. It takes maybe 1 minute or more or less to receive the email. I pause the record and it will come back when I receive this email, and you can click to activate it. When you click to activate it, you can enter any name. You can the choice is yours, and you can enter password as well and confirm the password and get started. This account will be created, and when you create this account, you will receive the link as well, and you can log in again with this link as well. This is the main page of the Snowflake. In the left side, you have several options. Project ingestion. In the ingestion, you can add data from AWS S3 bucket, Azure Blob Storage, Google Cloud Storage, and other storage. So, or Microsoft OneLake as well. And in this project, we have 3 SQL files for bronze, silver, and gold for Medallion architecture. I've already written these codes, and I will upload first, and we will explain more about this Medallion architecture. So let me first load the files. This is the 3 SQL server, the 3 SQL files, and in the bronze we have the raw data. Before diving into, let me explain a little about the user and role, and as well as virtual warehouse or computation resources in the Snowflake. So the all of the accesses in Snowflake are given based on the roles, and roles will be assigned to different users. So if you see here in the admin, in the governance and security, you can create the users and roles. So when you have several users, you can assign the role, a specific role to the users, and user can access some of the data, some of the databases, some of the schemas, and so on. So rules defines what actions a user can perform and what data they can access within the Snowflake environment. So as you can see here in the bronze, here we have account admin. Account admin is the topmost role to perform any activities in the Snowflake environment. And we have other roles like public security admin and so on. We can assign these roles to users, and with the help of this role, the user can access to certain database or certain schemas and certain data. So in terms of the compute, let me first show you a virtual warehouse in Snowflake, for example. And in the image, this is the image of the virtual warehouse computation in Snowflake. Snowflake has centralized location, shared disk, that multiple independent compute cluster can access to this shared disk, and it help us to have workload segmentations. For example, the larger warehouse or compute cluster that means large computation. If you need less compute, you can choose the less computation, and it makes the usage of the computation efficient, and make the usage efficient, and help us to have work segmentation. I mean, defining multiple warehouse for different type of activities. So we have various types of the computation, and it's gonna be X large, X small, small, and so on. We can choose every of them depend on your activity. So in this project, I have account admin because I've already created this work and this Snowflake account, and definitely I have privilege to do anything in the work in the Snowflake environment, and I choose the X small, the smallest computation. So the logical data organization in Snowflake is database, and the database is a logical grouping of the several schemas, and as well as schema is a logical grouping of the database objects, like such as tables, such as store procedure, stages, views, file formats, as you can see here, stage, file format, and so on. So first, we need to create a database and tree schema. When you go to catalog, you can see that hit refresh. You can see the this database and tree schema and two default schema that Snowflake uses for use that for metadata. So in project, in the bronze, yes, here you have access both, and you don't need to go back to catalog. Here we have a stage. Before running this code, let me type a stage in the Snowflake, and in the images we have this. This picture shows us that we have external stage and internal stage. In internal stage, table stage and user stage both are internal stage. Internal stage means it resided inside the Snowflake storage. So table stage is linked to a specific table in a Snowflake. When a table is created, a corresponding table stage is automatically created. Table stage is named after the table name, and it owns and managed by table owner. So when you have a user and the user has a privilege to create and creating this table and accessing this table, that user has access to table stage as well. So the use case of the table stage is when your files need to be accessed to multiple users and copy into a single table. It's the convenience, choice, and use case of the table stage. The same way happens for user stage. When you create the user stage with the same name as the table, as the user name will be created automatically, and user stage is a convenient choice as well. If your files will be only accessed by single user and but need to be copied into multiple table, the best choice is a user stage as well. For name stage, we have internal name stage and external name stage. As I said, internal stage is a storage, is the storage location that inside the Snowflake, and internal name stage. With the help of the internal name stage, you can load and unload data into it, and it will be created manually. Table stage and user stage created automatically, but the internal stage, internal name stage, and external name stage will be created manually, and you can use this internal stage as a location, as a storage location for loading and unloading data, as we use in this video as well. External stage is a stage and used to load data from external location. The external location is AWS S3 bucket, Azure storage, or GCP storage into a Snowflake table, or to export data from a Snowflake table to external destination. The the bridge between the Snowflake and the cloud storage is external stage. And for some internal purposes inside the Snowflake, with our use cases, we can choose one of the table stage or user stage or internal name stage. Before going ahead for bronze and silver and gold layer, let me first show you the JSON file. What is the raw data? This JSON file is the data related to solar renewable energy sites. It's nested JSON file. It location is a key. The key is location, and the value is nested JSON file, like lat-lang, altitude, name, and when you go further, you can see the location and a status that is under construction or something else, and the date of the production, and here some capacity with megawatts and panel type and number of panel, and here is a production records for this year, and per month is separated, and you have some integer value for the uh, production per month for this specific year 2025, this year 2025. So our purpose to that we want to in the gold layer uh, reach there is this star schema model. In the bronze layer we have this table is this column, and the last column is this nested JSON file. It's related to production record for this specific year. For example, this is the main data that we want to create the star schema on top of that. We have two dimensions, location and production. For location, we have this key column, and for production, we have three key columns. The combination of these key columns represent every record in the dimension table. And when we want to have the slowly changing dimension, type 1, we have to see all of these three columns to understand this record is new or have to update. For location, we use the ID. And this is the surrogate key for every dimension. And we connect these two dimensions to fact table, and this two value is related to numeric value we needed for business needs and for some analytical purposes. So this line of code first help us to create this stage, and with this code, with the list, we can see inside the stage is empty. And when you go to this schema, this database, and inside the bronze, we create the one database object, this is stage. And this is the bronze stage. And we can go to catalog. And here in the bronze, in the stage, in the bronze stage, we can upload the first JSON file. Let me go to JSON file, and this is the first JSON file. We can upload it here. And in project, in the bronze, when we run the list, we have to see this file in the internal name stage. This is the file format that represents that the file type is JSON, and this is the table that can host the JSON files as a raw data, and we can do the transformation, and we can create the star schema model on top of this table. With the help of this code, we insert the JSON file that already we've loaded into this bronze stage with this file format directly into this table that we are already created. It's all of them located the first column. As you can see, T is a alias name of this table, and T dot $1 is a first column because all of the JSON files is located in the variant type in the as a file, and you can access to all of the key values with the $1, and this is the key, and this is the key value inside, and you can access it with the like this location.name, location.geo.latitude, location.geo.longitude, and so on. And we can store this JSON directly into this table. If you run it, and 5 records loaded into this table, and this is the yes, EnergyDB database, bronze schema, and this is the stage. Let me copy paste the table, and here we can select, for example, asterisk from this table. Let me run it, and we can see this table, and in the silver layer we separate this column into 12 columns, and every column represents the production value for every month. Is one transformation we will do in this medallion to reaching the medallion architecture. In the silver layer, first introduce that we are using the database EnergyDB, and here we enrich the source string, and it's nothing but this transformation we use for every month. Let me run it, and let me see inside this table, and run it again. All of the columns are the same, but the only difference is here January, February until December, this transformation. And this table is ready to create the fact and dimension on top of that in the gold layer. So in silver layer, in order to implement fact and dimension, first we need to extract all of the columns we need for dimension. I name it source dim location and sim source dim production. Let me first create 2 tables. And here we merge into source dim location type 1 merging type 1 for a slowly changing dimension type 1. We use this code for this source dim location and for this source dim production. And we use the enriched source stream that we are already created here, this table. So this table, this is the source. When we load our data, transform data into table, we merge type 1 into source dim location and source dim production, and we selected just only the tables, the columns that we need for gold layer for finalized dim location and finalized dim production table. So let me first, before explaining more about these two dimension tables, let me first explain a slowly changing type 1 and a slowly changing type 2. So this is the picture that deeply explain two type, a slowly changing type 1 and a slowly changing type 2. The slowly changing type 1 and a slowly changing type 2, the only difference between these two this slowly changing dimension is history, is storing the history of the data. As you can see here in this table, we have customer ID, name, address, and phone. When this record resided inside the dimension table, when new record arrives and the address altered in a slowly changing dimension type 1, we override the updated records, but insert for both a slowly changing dimension type 1 and type 2, the insertion for both are the same, but for update part, the slowly changing type slowly changing dimension type 1, we override the existing value. As you can see here, new data directly replace old data in the database record. And no history maintained. Historical context is permanently lost once the update occurs. And for a slowly changing dimension type 2, as you can see here, we maintain two values, and you can see the former address and new address. And in order to separate the which record is old and which record is new, we have effective date and end date. When the new record with the same key value, I mean key column, not key value, key columns is customer ID, and you consider this first row, and we don't have the second row. When we have the first row, when new record arrives, first compare the customer ID. If the customer ID is loaded before, the slowly changing dimension type 2 try to see that is there any update for every column or more for one column or more column. In this scenario, we have the address column that just only the address column has been changed. For this reason, the end date changed from null to current timestamp, and the new record will be loaded as a and this record will be loaded as a new record, and the end date will be null, and the current flag will be yes, and the current flag for the former record will be no. And with the help of this end date and current flag, we can completely separate the old record with the new record. In terms of the insertion, When the customer ID 2 arrive for both table, this record considered as an insertion and new record, and the process for both slowly changing dimension type 1 and type 2 for both are the same. So here is this storage growth is a low and high because in the slowly changing dimension type 2 we need more storage, and is useful for trend analysis, for example, for financial uh, activity, financial data, slowly changing dimension type 2, in the most cases we use it. And for a slowly changing dimension type 1, just only correcting errors, for just only correcting errors for some scenarios that you need to store some data that your purpose to storing data in data warehouse model is only having the last updated data. The slowly changing dimension type 1 is suitable for you. Great. As I said before, in the silver layer we have two merge type 1, and we merge into the source dim location that we created here from using this enrich source stream, this table, and we check this column ID, as you can see here in this location. If this if the ID column from this source and this source dim location both are the same, we consider match and update the rest columns. If not match, if there is a difference between these two ID, we consider it as a new record and not match and insert it into the table. We do the same with the same as source dim location for source dim production, and the only difference is these three columns. We check all of these three columns. If all of them are the same, we consider as an update and update the rest columns. If one of them is different between upcoming records and resided records, we consider it as a new record, and we insert it into table. So we use these two tables as a source for the last version of the dimension tables, dim location and dim production. We use these two tables to create final dimension tables. In the gold layer, first we are using the database EnergyDB and create the dimension tables and fact tables. And here, as you can see here, the only difference between dim location and source dim location is this surrogate key, and for production as well. In the gold layer, we are what we are doing is creating surrogate key for dim production and dim location. And what is the surrogate key? Surrogate key is this column and this column. So instead of using these three columns, we use the simple integer to represent the key columns for dimensions, and is a primary key for this dimension table, and we can use this surrogate key as a foreign key in the fact table to make a connection between dimension and fact for the join in the data warehouse model. And here we created empty tables and fact, and the process is in the upcoming codes we are trying to add this surrogate key to dim location and dim production and create the finalized dimension tables. So in order to clarify and to make better understanding, I created the picture, this picture, to show you what is the process. So in this picture, I'm going to show you how to add surrogate key to source name location and source name production and create the finalized dimension table. Let me show you, let me close this. This query first capture the new records with the help of this function. Let me explain first these four functions. These four functions use the coalesce function and is this max process state. When you run this query for first time, because the dim location is empty, this coalesce return this date time, and for the count star that represents the number of records is returned as 0. For second round, it returns this value and it returns the maximum process state for dim location. And we did the same for dim production as well. Coalesce max process state and coalesce count star. We use these four functions to add the surrogate key to dimension and creating the finalized dimension tables. So this query create the view source and it capture all of the records from source dim location that's process state bigger than this value. In the first round, because the dim location, and as you can see here, this function dim location is empty, the process state definitely bigger than this date, and it returns all of the value in the source dim location. And as you can see here, this query is represent this query that I explained you. And when in the first round we left join between the source and dim production, as you can see here, this query, this SQL statement is left join between the source and dim location, and the output of this SQL statement is separating the let me close this, is separating the old value and a new value. The new value is a null value because in the left join, all of the records that there isn't any similar records in the dim production will be null, and it means that this records in the source is new, and for other records that is not null is old. As you can see here, we can separate and split this with the help of this SQL statement. For old temp is not null, and for the new temp is null. And we can split old records and new records in these two and loaded into these two tables, and we can take the this records from temp table that we uh, had from this SQL statement, and this SQL statement is left join between the source and dim location. This step, and is next step is first dropping the dim location key, and then create the surrogate key, and the surrogate key must be uh, in the continuing from the last surrogate key. And when we need to assign the surrogate key to new records, it's gonna be continuing from the last surrogate key. In order to continue from last surrogate key, we need this function, and this function is the count of the star. The first round is 0, and the second and third round is count star. And we can use this function roll number or ordered by ID and plus this function that returns the count star. And we can add this surrogate key just only in the new temp enrich, is like this, new temp enrich, and then we union all the old temp and new temp enrich. New temp enrich is this new temp enrich use this table, and this table uh, is new records, and with the help of raw table we add the surrogate key from the uh, last surrogate key that added to this new temp enrich table. And when union all is a table that you can see here, this table is combined of the two, and we can use this main SRC table as a source for merge type 1 to the dim finalized dimension table. And this record help us to uh, merge type 1, and the merge type 1 for the old records in this table we update with merge type 1, and for new records we insert. I did the same for the production as well. First, using the where clause to take the new records from source, and then left join, and here separate the old records with split the old record and new records with the help of the null or not null, and then using the raw number over this function, and this function return the count star, and we add the surrogate key, and then union all, and then merge. The only difference between these two merge is in the production we have 3 columns to compare, but in the location dimension we have just only ID. So I forgot to load, I've already here in the catalog, if you see, let me enable, I loaded this JSON, but I forgot to insert into silver layer. In the silver layer, the first JSON file we have to expect to have 5 here, 5 number of the row inserted, and for the production as well 5. And you can see here if you select from this table, for example, uh, here this table, uh, this table, let me run it. You see 5, and let me check. Yes, sourced in production, and let me run it, and the 5 records is here. So let me go to gold. First use the database. I think so I've already created the let me see. No, let me run it, and this. Okay, and let me go down. First we have to create the functions. In the catalog, let me refresh. The functions as located in the gold schema. If you see, functions is an object, database object that is here that I mentioned the first of the video. The function is inside the schema. So let me run this bunch of codes for creating the dim location. We expect to have 5 records because because it's the first round. 5 number of row inserted 5 and update 0, and we expect to have the same for production, 5 inserted and 0 updated. So let me explain about the fact. Fact is nothing but the left join between the source and dim location and dim production and the key columns, as you can see here on the key columns. So we make a left join and we take the dim location key and dim production key for further relationship in the data warehouse model between the dimension and dimension tables and fact table. Let me run it, and we expect 5 here. It's created, and we have source fact. And the reason we have a source fact is in this scenario, when we in the second round, if we have the same columns as you can see here, and the current timestamp will be changed, and we don't want to have duplicate records in the fact table. For this reason, in the current timestamp, if the second round has the same columns as these columns and with different current timestamp, the only thing we need to do is merge type 1 in the fact and compare it to all of the columns. If all of the columns are the same, we updated this with the last current timestamp. If is there any difference between these columns, we inserted and consider as a not match. The reason behind I use this merge again, I try to prevent to have the duplicate records when all of these four columns are the same and current timestamps for with the different current timestamp. We try to use the merge to prevent the duplicity of the records in the fact. So let me run this query, and when we run this query, we can definitely see the 5 inserted records, and we can check dim location, and you can see the surrogate key for dim location and for dim production, and this is the dim location, and we can see the result. And for fact you can see the 2 foreign key for dim tables and capacity and panel count as the 2 measurements for ANILCA purposes. In order to demonstrate the data warehouse model is loading changing dimension type 1, we need to load new JSON file. Let me open the first JSON file we have already uploaded into Snowflake, and this is the let me take one JSON, and what we're gonna do, we're gonna change the name of this record, and it's in accordance with our data warehouse model. We change the name. We have to have one update just only in the dimension location, and nothing in production, and as well as nothing in the fact. That is save. Let's go to catalog. Let me see. Can I remove this? Yes. Browse and upload this. Let's see. Okay, and go to bronze. This is the bronze. Let me first see the list is only 2, and then create the source again and insert. We are simulating the streaming processing with the Snowpipe. It's gonna like Snowpipe by deleting, adding new file is like streaming ingestion, because we want to demonstrate the data warehouse model. So one record added into this, and let me see the let me go to silver, and here transformation, and we don't want, let me merge it, one updated in location, and nothing happened in one updated number of rows, because is updated as well, but nothing happened. I mean, I change here, this record already is here, but it's just only updated, but nothing happened in the dimension production. So let me go to gold, and let me we don't want to run the dim and function as well. Let me run this query for surrogate key for dim location, and for surrogate key for dim production. Let's see. And for fact, let's merge it. Nothing happened. One update. And if we see, let me open. For dim production, what was the 995, and this record is already resided, but this updated, but nothing happened. But for dim location, we're gonna see here, and yes, it's updated, as you can see. And for fact, we don't have anything, and I don't know what is the let's see the location, and it's 5. And for fact, it's 5, yes. And let me test another JSON file. In this JSON file, I want to change, for example, a status, only a status. And when I change the status, it's considered new record for dim production. Let me first remove this file and go to here to first one and try to select this JSON file, and let me change this status here. Status here, status operational. Let me change it to, for example, let me change it to, for example, decommission. Decommission. And let me, it's a new record in the dim production, and let me change, for example, let me dim production, let me change the capacity as well. We wanna see that fact table will be affected or not. We expect to have the change on the fact and new record into dim production. Let's save it. Go to here in add new file. I save, yes, I save it and upload. And let's go back here in bronze. In bronze, we have to create source again, insert again, and here in the silver, you can see, yes, this. And we don't want to create dimension, we want to merge it. Let's see, verge 1 number updated, nothing happened. And for production, 1 inserted, yes, 1 inserted because we changed the status. And for gold, yes, for gold, we have to see We don't want this, we don't want function, we already, let me add surrogate key, and this this query, nothing happened, but for dim production, we expect to have one surrogate key more. Let's see. And for fact, we need one insert. As you can see, let me explore. This is the dim production, and we can see the fact. But in dim location, we have 5, and for fact as well, we have 6, and this one added to. In this, let me see the. I forgot. I add 2 0 digits to capacity. I think so. Where is it? Capacity. Yes, we add 2 zeros here, and it works well. Let me do the last. Yes, let me do, for example, yes, let me do this. Let me take, for example, the first one, or the second one, no worries, can take the second one. Oh, let me do like this. It shifts, and here, yes, and paste it here. And what we're gonna do, we're gonna change the value here. For example, for March, I wanna add 30, and in accordance with the structure, it changed, and we have to have one update in production. Let's see. One update in production, yes, and nothing happened for the fact and the dim location. Let's see. Let me go to bronze. First, go to stage, remove it. We save. Let me add this second file, and let me go back to bronze, go up, and let me list it first. We have one, and go to create again source and insert. So yes, we can go to silver, we can go up, and here transformation, and don't want to create, let merge it. Is one update, nothing happened. And for production, yes, one update. And let's go up, and here you can see create, we don't want, function we don't want. Let me see and copy both dimensions for surrogate key. Let's see. Okay, fact, nothing happened. For fact, nothing happened. Let me see as you can see, is a 6. And for March, for second one, for March is like this, is updated. Found this video helpful. If you enjoyed this session and want to keep learning more about Databricks, Microsoft Azure, Microsoft Fabric, Snowflake, DevOps, Terraform, DBT, and so on, make sure to subscribe the channel and turn on the notification bell. I'll be posting more hands-on tutorials and real-world data engineering project. Thank you for watching. If you have any question, just leave a comment. Bye for now.